Okay, so in this video, I'm going to start from question number 12. And in my previous video, I have solved from question number 1 to question number 11. So in this question 12, see the problem. In the given figure, so this is the figure, two circles touch each other externally at the point P. So this is the point where these two circles touch each other. That is P. Okay. Now AB is the direct common tangent of these circles. So that is the common tangent of these two circles. Okay. Now you have to prove that tangent at point P bisects AB. So that means if you draw the tangent at P, it will be like this. So it will cut AB at point, suppose this point is D. Then you have to prove that tangent at point P, that is the bisect that bisect this AB. That means AD is equal to DB. Okay, that you need to prove. See, here D is an exterior point from where two tangents are there. So from D, there are two tangents, DA and DP, to this circle, first circle, whose center is O. Okay, so what you can say, DA is equal to DP and DP is equal to DB, because this is DB and DP, these two tangents, these are two tangents of this circle. Okay, so you can write DB equal to DP. Okay, so from here you can say DA is equal to DB. That means tangent at point P that bisect AB. So this is the proof. Okay, so the first part is proven. Now the next part. See, angle APB, this angle is 90 degree. You have to prove that. This is 90 degree. You have to prove that. Okay, now first you need to join this AO and BO, and you need to join this one, O and O dash. Now see one thing, since DA and DP, they are equal, so angle DAP is equal to angle DPA. So since ADP is an isosceles triangle and DBP, that is also an isosceles triangle, so you can write DBP, angle DBP is equal to angle DPB. Okay, so this is the point P. Now angle APB is angle APD plus angle BPD. Okay, and these are, so that will be equal to, now ADP or APD or DPA, that is equal to DAP plus instead of BPD you can write DBP, so angle DBP, right? You can write like this. Now in case of this triangle ABP, you know that sum of three angles is 180 degree. So BAP plus APB plus ABP is equal to 180 degree, right? Now see, instead of APB, you can write this one. So angle DAP and DAP plus DBP, that you can write. Now DAP and BAP, they are same. So you can, this is just twice of this one, right? So 2 into DAP plus DBP is equal to 180 degree. You can write like this, right? See, I'm explaining one second. BAP, that means BAP, that means DAP. So this is nothing but DAP plus APB. Instead of APB, you can write DAP plus DBP. See, ABP, APB. Instead of APB, you can write this one. So DAP plus angle DBP, right? And this ABP, that is DBP, this angle, simple. So plus, you can write DBP, that is 180 degree, right? So you can write, after this step, you can write this step, this one. So from here, you can write angle DAP plus angle DBP, that is half of 180, that means 90 degree. So that means angle APB, this angle is equal to 90 degree. Okay, understood? This is the second part, angle APB, that is 90 degree. Now see question number 13. See, this is a circle. A is an exterior point. Two tangents are there, AP and AQ, drawn to a circle, this one. And you have to prove, angle PAQ is twice angle OPQ. Okay, so this angle and that angle. So PAQ, this one is twice this angle. Okay, now see two triangle. Now see one thing, I have joined PQ chord, and since A and I have joined A and O, so that will be perpendicular to PQ. Why? Because this is a chord joining this 2 point on circumference. So PQ is a chord. Okay. Since A is the exterior point and AP and AQ, they are two tangent of this circle, and OP and OQ, they are equal. They are radius of this circle, same circle, radius of same circle. Okay. So here these two angles are equal. APO, angle PAO is equal to angle QAO, and angle POA is equal to angle AOQ, right? In question number 11, we have already proved that joining this OA is perpendicular bisector of QP. Okay, so you can write OA is perpendicular bisector of PQ. Okay, so this four angle, they are 90 degree. These are 90 degree. Okay, now see see this point. Suppose OQ, OA and PQ, they have intersect at the point D. Okay, at the point D. So in case of this two triangle OAP and triangle ODP, in case of this two triangle, what happens? See this. In case of this two triangle, OP is common side, angle PDO is equal to angle OPA. See, since this is tangent, that means OPA, that is this angle is 90 degree. So this is equal to 90 degree. And one angle is also common. Angle POA is equal to angle DOP. Okay. So from this situation, see, from here you can say AA postulates, right? AA postulate. From AA postulates, you can say PDO, triangle PDO is similar triangle APO. And so from here you can say angle PAO is equal to angle OPD or OPQ. Okay, that you can say, since these two are similar. So this angle and that angle, this one and that one, these two are similar. Okay, now angle PAQ is equal to sum of PAD or PAO plus DAQ, and these two angles are equal. So you can say PAO and QAD, PAD and QAD, they are two equal. So 2 into angle PAO, that you can write here, and this will be equal to 2 into OPD, since PAO is equal to OPD. So you can write like this. See question number 14. AB is that is 12 centimeter. AC is 13 centimeter. Okay, so this is a right triangle. So BC, you have to find, first you have to find out BC. Okay, so BC will be root under 13 square minus 12 square. Okay, so that will be 13 square means 169. 169 minus 144. So if you subtract, it will be 25, root 25, that means 5. Okay, so BC is 5 centimeter. Okay, so this one is 5 centimeter. Now see, if this is X, that means if you rename this 2 point, this is P and this is Q, then BQ is X centimeter and BP is also X centimeter, right? So AP is 12 minus X centimeter, 12 minus X centimeter, and QC is 5 minus X centimeter, 5 minus X centimeter. Okay, now see one thing, this A, B, C, these are 3 exterior point from where tangents are drawn to each to this circle. Now this point is the point where the tangent is drawn, that is P, Q, and this one is R. Okay, now see, AP is equal to AR. So AR is also 12 minus x, because AP is 12 minus x, so AR is also 12 minus x centimeter, and this QC is equal to RC, so RC is also 13 not 13, for 5 minus, this is 5 minus x, so RC is also 5 minus x centimeter. Now see AC. AC is AR plus RC, so that will be 12 minus x plus 5 minus x centimeter, and that is equal to 13 centimeter. So if you join 17 minus 2x, that is in centimeter, that will be 13. So 2x is equal to 4. So x will be 2 centimeter. Okay. So x will be 2 centimeter. So this is the radius of inscribed circle. Okay. See, in case of question number 15, in a triangle ABC, the incircle center O touch BC at the point P, CA at the point Q, and AB at the point R. Okay. See, one thing is given to you. See, you have to calculate QOR. That means, so you need to join. If you join OR and OQ, see QOR. So that means this angle you need to find out, and you have to find out QPR. See, QPR and QOR, they are on same segment QR. So once you have found this QOR, will easily get this QPR, because QPR is half of QOR. Okay, Q angle, so you can write like this, QPR, that is half of angle QOR. Now you have to find out angle QOR. Now before that, you just need to you just need to join A and O. So if you join A and O, see, A is the exterior point, and you have drawn AR and AQ, both are tangent to this circle. That means from the corollary of theorem 10, what you can say, this RAO, angle RAO is equal to angle QAO, and sum of these two is 60 degree. That means this will be half of RAQ, half of 60 degree, that is 30 degree, right? Now say in case of, and these two angles are also equal, that is also according to the corollary of theorem 10, this two angle, that means AOR, that is equal to AOQ, that is equal to half of angle QOR. Okay, now see this triangle, any one of, now in case of triangle AQO, this angle is 90 degree, so sum of these two angle will be 90 degree, so this is 30. So in case of triangle AQO, angle AQO is 90 degree, right? Angle QAO, that is 30 degree. So angle AOQ, that will be 90 minus 30, 90 mingle 30, so it will become 60 degree. So since this one is 60, this one is 60 degree, so that means this one, so you have got AOQ. AOQ is 60 degree. Now this is 60 degree, that is the half of QOR. So that means from here you can say angle QOR will be 2 into 60 degree, so that will be 120 degree, and angle QPR, this is the answer of question number 1, and QPR, that is the answer of question number 2, that will be half of QOR, QPR, that is half of 120 degree, that means this will be 60 degree. Okay, so this is the answer of question number 1, and this is the answer of question number 2. Okay, so question number 16. See, in the given figure, PT touch the circle with center O at the point R. So PT touch the circle at point R. Okay, O is the center, and SQ is the diameter SQ, and SQ produced meet PT or tear at the point P. So now it is given that SPR, this angle is X. So this is X. See, I have drawn the same thing. SPR, this angle is X. QRP, this angle is Y. Now you have to prove that this angle is also Y. Okay, so now from this given figure, one thing you can say, see this triangle, in case of triangle QPR, this one, see OQR, this angle OQR, this is the exterior angle of this one. Okay, so angle OQR, that is sum of this angle and that angle, QPR plus QRP. You can add these two things. Okay, so this angle will be X plus Y. QO, OQ and OR, they are two radius, same radius of same circle, so they are equal. So OQ is equal to OR, right? So that means triangle OQR, that is an isosceles triangle. That means angle OQR is equal to angle ORQ, that is equal to x plus y. Okay. Now see one thing. This is SQ. SQ is the diameter. So SQ is diameter, and angle QRS, that is angle on semicircle. Angle on semicircle. So that means angle QRS, that is 90. This is 90 degree. This one. And PR or PT. PR is tangent to the circle. That means ORP, that is 90 degree. Right? Now you can say QRS, that is equal to this one. This angle is S or else ORS plus angle ORQ. This is ORS plus ORQ, that you can write ORS ORQ. Okay, this one. And this 90 degree, this is ORQ plus this, sum of this two angle is also 90 degree, and sum of this two angle, that is also 90 degree, right? And here OQR is common. So this is ORS plus ORQ and ORQ plus QRP. So that means from this two equation, what you can say? Angle ORS is equal to angle QRP. So that means Y. So this is proved. First part. Okay, first part is proved. Now, see the next one. You have to write an expression connecting X and Y. Now see. So this is Y and ORQ. ORQ is X plus Y. So that means you can from 1, you can say 90 degree is equal to ORS. Instead of ORS, you can write Y. And in case of ORQ, you can write X plus Y. So 2Y plus X, that is 90 degree. Okay. So this is the expression. Okay, connecting X and Y. This is the answer of question 2. See, in case of question number 17, PT is the tangent of this circle and BAC is BAC, this angle. This angle is 70 degree. ACB is 50 degree. So in case of 17, first find out angle CAB, that is 180 degree minus 70 plus 50. Okay. So that will be definitely 60 degree. Okay. Now see, CT, this angle is this one. CT is perpendicular to PT. So that means CT is the diameter. Diameter will always perpendicular to this tangent. Okay. So CT is the diameter. That means angle CBT is angle on semicircle. So it will be 90 degree. Okay. So this is the answer of first one. CAT, that is also angle on semicircle. So angle CAT, that is also 90 degree. Right. So angle BAT, that is angle CAT minus angle CAB. Now CAB, this one is 60 degree. So 90 minus 60, that will be 30 degree. Okay. So BAT is 30 degree. That is the answer of 2. Now you have to find APT. Now angle BAT, that is the exterior angle of this triangle APT. So APT plus angle ATP, that is angle BAT, that is 30 degree. Okay. Now see, this ATP plus ATC, that is 90 degree. Since angle CTP is equal to 90 degree, and that is sum of angle CTA plus angle ATP, right? Now CTA is equal to CBA. See, angle C, you can write angle CTA is equal to angle CBA, that is 70 degree. Okay, that is 70 degree. Why? Because they are angle on same segment. Okay, so CA, angle on same segment CA. So this angle is 70 degree. Okay, so this angle is 70 degree. So 90 minus 70. So that means angle ATP, that is 90 minus 70, that is 20 degree. Okay, ATP is 20 degree. Now ATP and PAT, that is sum of this two angle, that is 30 degree BAT. So that means angle APT, that is 30 degree minus 20 degree, that is 10. Okay. So APT, that is 10 degree. So this is answer of 3. Now see question number 18. O is the center of the circle. PA and PB, they are two tangent. Okay. Now AOB is given. AOB is 140 and APC, this angle is 80. Okay. Now if you join O and P, if you draw it clearly, it will be like this. So this is the diagram, and if you join this one, so this angle is 90 degree. This is 90 degree. This angle is half of 80 degree. Angle APO, that is half of angle APC, that is half of 80 degree. So that will be 40 degree. Okay. So this is 40 degree. Now if this one is 40 degree, so AOP, that will be 90 minus 40 degree. So angle AOP, that will be 90 minus 40 degree, that is 50 degree. Okay. So this one is 50 degree. Now if you join this one, OC, you will get the entire M1, and according to that corollary of theorem 10, AOP and COP, they are equal. So this one will be 50 degree. So AOC, so that means this one is equal to COP, and that means angle AOC, that is 100 degree. Okay. Now angle AOC is 100 degree, and ABC, they are on same segment AC. AOC at center and ABC as circumference. So angle ABC, that is half of this one. So this will be 50 degree. Okay. So this one is 50 degree. This angle is 50 degree. Okay. Now this angle is given, that is 140. So AOP, since angle AOB, this is 140 degree. So angle ACB, that is half of 140 degree. So that means this is 70 degree. So ACB is 70 degree. This one is 70 degree. Now this angle, you just need to find out this angle BAC. So BAC, angle BAC, that will be 180 minus 70 plus 50. ABC is 50 and ACB is this one. So if you subtract 60 degree, BAC is 60 degree. Question number 19. See, PQ is the tangent of the circle at point A, and AB is the bisector of CAQ, and so AB is the bisector of CAQ. That means this angle is equal to that angle. Okay. And AD is the bisector of PAC. That means this angle is equal to that angle. Okay. Now BAQ is given, that is 30 degree. You have to prove that BD is the diameter. BD is the diameter. If you can prove that BAD, this angle is 90 degree, then this angle will be angle on a chord. BD is a chord, and angle that is on that chord, that is 90 degree. That means that chord is diameter. So here you can say angle BAQ is 30 degree. Okay. So that angle BAC, that is also 30 degree, since AB is the chord of angle CAQ. Okay. Now see, the entire one is 180 degree. So if you subtract, so 30 plus 30, so angle CAP is 180 degree minus 30 plus 30 or 60, whatever you can write. Okay. So 180 minus 60, so that will be 120. Now CAP is 120, so that means CAD. So that means angle CAD, that is half of 120, that is 60 degree. So that means this angle is 60 degree, this angle is 30 degree. So angle BAD, that is angle on the chord BD, that is equal to angle CAD plus BAC. So that will be 60 plus 30. So it is 90 degree. That means BD is a diameter of the circle.